Answers to assignment questions. Questions 77 to 89. Question 77. You have to find the heat capacity of your cup of water. The power of the heater is 35 watts. First, you have to find the energy transferred to the water in 300 seconds. Then, refer to your data to find the temperature rise in the corresponding period of time. Lastly, apply the formula C equals Q over delta T to find the heat capacity of your cup of water. Question 78. Why foam cup was used? Because foam is a better heat insulator than glass, so that heat loss to surroundings is reduced. Question 79. Why we should have a lid? Without a lid, there will be a lot of evaporation, and then there will be a lot of heat loss to surroundings. Then the temperature will rise more slowly. Question 80. What's the use of the stirrer? It is used to mix the water well so that the temperature of water is uniform. Question 81. Why we have to ensure the heater is totally immersed in water? Because otherwise there will be very large heat loss to surroundings. And more importantly, the heater may be overheated and then it may melt itself. Question 82. The temperature rises for a short time after the heater is turned off. How to measure the temperature rise more accurately? We should measure the highest temperature reached after the heater is turned off, and then we have to find the difference between that final highest temperature and the initial temperature. Question 83. There's one thing that may affect the heat capacity of your cup of water, and that is the mass of the water. Question 84. Calculation questions. For that small cup of water, it has a small capacity of 300 joules per degree Celsius. The water may absorb totally 1,500 joules of energy when its temperature increases by 5 degrees Celsius. You should apply equation 5. In order to produce the same amount of energy, 1,500 joules, a 20-watt meter have to operate for 75 seconds. Question 85 is a big piece of rod placed under the sun, and it is absorbing the energy from the sun at the rate of 500 watts, that is 500 joules per second. So that in 5 minutes, it will absorb altogether 150,000 joules of energy. The heat capacity of the rod is 10,000 joules per degree Celsius. You may then apply equation 6 and find the temperature rise of the rock. But the temperature rise of the rock usually is smaller because there is heat loss to the surroundings. Question 86. Simply apply the formula Q equals C delta T, where Q is 8,400 joules and temperature rise delta T is 5 degrees Celsius. And so the answer is 1,680 joules per degree Celsius. Don't forget to write the correct unit. Question 87. Using the above information, find the heat capacity of 1 kilogram of water. Just now, in the last question, that 0.4 kilogram of water has a heat capacity of 1,680 joules per degree Celsius. And so, for 1 kilogram, which is 2.5 times larger, the heat capacity would becomes 2.5 multiplied with 1680, and so the answer is 4200 joules per degree Celsius for that 1 kilogram of water. After calculating the heat capacity of 1 kilogram of water, let's move on to calculate the heat capacity of 1 kilogram of aluminium. In question 88, you are given a 2 kilogram aluminium block which absorbs 3600 joules of energy to increase the temperature by 2 degrees Celsius. So to increase the temperature by 1 degree Celsius, it absorbs 1800 joules of energy. And this is a 2 kilogram aluminium block. For a 1 kilogram aluminium block, it absorbs half the energy, which is 900 joules per degrees Celsius. Lesson 6, pre-lesson video, section 3.2, specific heat capacity. Just as the last two assignment questions have shown you, it would be more convenient to tell the heat capacity per kilogram of a substance. And we call this specific heat capacity. The specific heat capacity is thus equals to the heat capacity divided by the mass m. And so, given by equation 8, Q over m delta T. Note that the capital letter C stands for heat capacity, while the small letter c stands for specific heat capacity, which is the heat capacity of 1 kilogram of substance. So that you may use equation 9 quite often, in which Q is the energy supplied, m is the mass of substance, and delta T the temperature rise. And the small letter c is specific heat capacity. For example, the specific heat capacity of water is 4200 joules per kilogram per degrees Celsius. And what does that mean? That means for 1 kilogram of water, it absorbs 4200 joules of energy to increase its temperature by 1 degree Celsius. The specific heat capacity of water is relatively high when compared with other substances. And note that we talk about specific heat capacity of pure substances only. For combined object, then we use heat capacity instead, such as an electric kettle because it has a metal body and a plastic handle, and the specific capacity of metal and plastic are very different. In the coming lesson, you are going to do an experiment to find the specific heat capacity of water using a calorimeter together with a joulemeter to measure the energy supplied to a fixed amount of water. You will measure 200 cm cube of water and pour it into the calorimeter, and to supply energy so that its temperature increases by about 8 degrees Celsius. About 8 degrees Celsius. You may find the temperature rise accurately by measuring the maximum temperature reached when the heater is turned off. And then you may apply that equation 9 to find the specific heat capacity accurately.